Hi, this is Wendy Lightheart, and in this video we are going to be solving some application problems which we would call variation problems, sometimes called modeling using variation. There are some application problems where you will see phrases like varies directly as, or varies inversely as, or varies jointly as. These problems are called variation problems, and there is a formula associated with each type of variation. So with direct variation, you might see it commonly phrased as y varies directly as x, where y would be representing some quantity and x would be representing some quantity. And the formula that you would use for direct variation would be y equals some constant k times x. With inverse variation, the common phrase would be y varies inversely as x. And again, y is just representing some quantity and x is representing some other quantity. And so if y is the quantity that's varying inversely as x, then the formula would be written as y equals some constant k divided by x. And then with joint variation, it's very similar to direct variation, although we have two variables that y is varying directly as, both x and z. So that's why we call it joint variation. So the formula for joint variation, if y varies jointly as x and z, would be y equals some constant k times x times z. You'll notice that all of these formulas have a k in them, which I've called a constant. And we call this k the constant of variation. So how do we solve variation problems? Here are the steps that we're going to be following. The first thing we need to do is determine the type of variation that's being described, and this will indicate what formula you're going to be using. The second step is to find the value of k by substituting into the formula the given values of y and x, and possibly z if it's joint variation. And the values that you're plugging in are those values that are given to belong together. So if they tell you that this y goes with this x, then those are the values you're going to plug in order to find k. So once you substitute those into the formula, then you'll solve that equation for k. Then you're going to use the same formula again, but this time you're going to plug in the value of k that you found in step 2 and the other given values for the respective variables. So for example, you might be given another value of x and you want to know what value of y belongs to that value of x according to this particular variation problem. So you'd plug in the k that you found and you'd plug in that known x value and then solve to find the unknown y value. This will make a little more sense once we go through an example. And then step 4 is to solve for the unknown variable and then state the answer, being sure to include units, because all of these are going to be application problems, so your answers will need to have units on them. Okay, let's look at an example. For our first example, it says it is given that y varies directly as x. And suppose y equals 56 when x equals 4. And what we want to find is what is y when x is 20. So the first thing we have to do is determine the type of variation, and that will tell us what our respective formula is going to be. Notice that we see the phrase y varies directly as x. Note that sometimes this might be worded as y is directly proportional to x. That just means the same thing. So when we see that it's direct variation, we're going to use the formula y equals k times x. So now we have our formula, and we're going to use the value of y and x that we're told go together in the problem, which are the 56 for y and the x is 4. So that's because it says y is 56 when x equals 4. So we're going to plug 4 in for x and 56 in for y. So we're told that those two values go together. And we're going to use that information to find k, because k is a constant. So now we're going to divide both sides by 4 to solve for k, and we get k equals 14. So now we're going to use that formula again, but this time we're going to use the value of k that we just found. And then what we're trying to find is, what is y when x is 20? So we're going to plug 20 in for x, along with the 14 we found for k. And if we solve this for y, that will tell us what y is when x is 20. So we get y equals 280. Now this problem was a simple problem. There were no units involved, so we don't have to worry about units on our answers, but most of the time you will need to include units on your answers. Let's look at another example. If the temperature is constant, the volume that is occupied by a gas varies inversely as the pressure that is applied. A particular gas occupies 24 cubic inches when 14 pounds per square inch of pressure is applied to it. And what we want to know is how much pressure must be applied for the gas to occupy 50 cubic inches. So the first thing we need to do is determine the type of variation that's being used here, and then that will tell us what our respective formula is going to be. So you're looking for the phrase that tells you the type of variation, and it's right here, varies inversely as. Now we have to figure out what is the y and what is the x. So here it says the volume that is occupied by a gas varies inversely as. So the y is going to be the volume, and it varies inversely as the pressure that is applied. So the pressure that is applied is going to be our x. So here is our formula for inverse variation, and we're going to substitute the given values for x and y. Again, note that y is the volume and x is the pressure. Now look for the two values for volume and pressure that we are told belong together. Notice it says for a particular gas, it occupies 24 cubic inches, so that's a volume, when 14 pounds per square inch of pressure is applied. So that's a pressure. So when the volume is 24 cubic inches, the pressure is 14 pounds per square inch. So those two values belong together. So we're going to substitute in place of the volume, which is our y, we're going to put 24 in there. And then in place of the x, which is the pressure, we're going to plug in 14. And that's going to help us to find the k for this particular gas. So now we solve for k, so multiplying both sides by 14 will help us to solve for k. And when you do that, you should get 336. And remember, k is just a constant, it's just a number, and that's going to be used to help us find how much pressure must be applied for the gas to occupy 50 cubic inches. So now we use the formula once again, the same formula, the y equals k over x, but this time we're going to replace the k with the value we just found for k. And then since we want to find the pressure when the volume is 50 cubic inches, we're going to put 50 in for y, because remember y is the volume, and we're trying to find the x that goes with that. So we plug the k in and the y in, and now we solve this for x. So if you cross multiply, you could think of this as a proportion and cross multiply, or you can multiply both sides by x and then divide both sides by 50. Anyway, go through the proper steps to solve for x, and you should get x to be about 6.72. Now this is not our complete answer because of course we need units on our answer in this case. And remember the X represented pressure, and the pressure is measured in pounds per square inch. So 6.72 pounds per square inch of pressure would need to be applied in order to get a volume of 50 cubic inches. Okay, let's look at another example. The kinetic energy of an object varies jointly as the mass of the object and the square of its velocity. The kinetic energy of an object having a mass of 300 grams and traveling 2 meters per second is 224 joules. What is the mass of an object traveling 5 meters per second and generating 320 joules of kinetic energy? Wow, that's quite a mouthful. Lots of words there, but it's okay. We're just going to follow the steps and hopefully we can figure this out. So remember, the first step is to determine the type of variation. So look for that common phrase. You're actually looking for the word varies. And so if you look for the word varies, this says varies jointly as. So this is joint variation. And the kinetic energy is what varies jointly as something else. So the kinetic energy is going to be our Y. And with jointly, there's going to be two or more quantities that Y varies jointly as. So in this case, the mass of the object is one of those. So we could call that the X. And the square of its velocity. So it's not just velocity, but it's velocity squared. So we're actually going to use a Z squared for the second part that is Y varies jointly as. So then, here's our formula. Y equals kx times z squared. It's a little bit different than our formula we saw originally because we need to have the square of the velocity, not just straight velocity. So the steps are still going to be the same. We're going to plug in the x, y, and z that we are told belong together. So remember that the y is the kinetic energy, and the kinetic energy is measured in joules. So 224 is the y that belongs with the 300 grams and the 2 meters per second. So the mass is going to be our x, and the speed or velocity, 2 meters per second, is going to be our z. So when we plug those values in, this is what we get here. And so now we're going to solve this for k. So if you multiply out the right side and then divide both sides by that number, in this case, if you divided 224 by 1200 is the number you're dividing both sides by. Once you simplify that, you're going to get a decimal number that keeps on going. It's not a nice decimal that cuts off. And so instead of rounding that decimal, in order to make sure your answer is accurate, just reduce the fraction or even use the exact fraction. It doesn't even have to be reduced because we want to make sure we're as accurate as possible. So we're going to use 14/75 as our k, which is the reduced version of the fraction we get. And now we're going to do the next step, which is to plug in that value of k into that original formula we started with. And this time we're looking for the mass, so we don't know what x is, but we know that the z is 5, because that's the velocity, and the kinetic energy is 320, so that's going to be our y. So we plug those values into the formula, and we solve this for x. So if you multiply the x times the 14/75 and times 5 squared, you'll get a fraction times x. Multiply both sides by the reciprocal of that fraction to solve for x. And now it's okay to round because we're just trying to find our answer. And so if you plug that in to your calculator and round it to the nearest tenths place, you should get about 68.6. So the object's mass is about 68.6 grams. Okay, so for each of these variation problems, notice that all the steps were the same. We just would have a different formula depending on whether it was direct, inverse, or joint variation. Alright, so it's your turn to try your own. Good luck!